we will also change the language in English. So we have Stefan Oschner, project manager and architect from ARCO architecture company, will talk about transition towards a carbon conscious design method. Go ahead, Stefan.
Thank you very much for the introduction. I just noticed my title is quite long, probably quite difficult to understand at a grasp. So what I want to tell you is a little bit, we have been listening to many other speakers as well. There's a lot to learn. We are in this kind of phase of transition. There's a lot to learn, a lot to change in our behavior. And I want to put a little bit the focus on what do the architectural offices at the moment do to learn all those new things and to create better buildings. And my name is Stefan Oxner. I'm working for ARCO, an architectural firm, a Finnish firm. We have been merged by multiple smaller companies. We have offices in 4 cities in Finland: Oulu, Turku, Tampere, and Helsinki. The company is quite large. We have 175 people working for us. And the range of things what we do is in the same way large as the company is. Myself, I'm originally from Germany. That's why I'm sorry not being yet so great to stand here on the stage and doing the speech in Finnish. But I'm leading in ARCO, I'm leading the sustainability development team and also the international division of ARCO. If you see the project range that the company is doing, you see there's hardly anything left out. And also because of that, if you're so large and if you're handling so many cases, you should also be quite responsible, and you should turn maybe faster than a small firm can to all these new demands what we have on the table today. And the melting ice here in the background and the question mark and the exclamation mark, I know that everybody is very well aware. Everybody knows that we are either at the start or in the middle of a really, really bad crisis. And just to make us all feel a little bit worse, we all know that we are part of the problem, and we are quite a big part of the problem. And we know that construction business is a huge emitter. We are also using 50% of all the raw materials that we excavate on the planet. That's quite a lot. And we are also responsible for 35% of the waste that is put on the planet. So we should feel a little bit guilty. But on the other hand, we have also great opportunities to make things better. So we should understand where we are in the system, understand where we are in the problem-making things, and understanding that we really have to move. We really can't wait anymore. And we can't really let those frightening graphs, what we see here on the screen, we shouldn't let them grow anymore. The one on the left, I'm not going much into detail. I know you have seen them all. Shows the greenhouse gas emission concentration in the atmosphere. We know where we are today. We have crossed the warning signs, and we will cross them further. These dotted lines, we know that the carbon concentration should go down. We can't continue like this. But I'm also pretty sure that what I sketched here, because the diagram was ending, what I sketched here is probably too optimistic. And why is it too optimistic? And that's the reason of the curve on the other side. The reason is that there's still an immense growth of population on the planet. We are growing probably until 2080 quite a bit. And related to this population growth, we have a need for constructing things. So how can we actually do that? We know that we have to construct more. We can't just stop building, but we also really understand that we can't continue as we have been doing until now. We know that we can't emit the same way as we have been doing it in the past. Well, I'm a little bit naive probably, but I think the problem what we have here is man-made, and therefore the humans should be also the ones that can fix it. And 3 terms down here on this slide, how we can fix it. I know it's not that simple, it's very complex, but in principle, you can fix it by reducing, reusing as much as you can, and to sequester. Take care that the carbon that is emitted doesn't reach the atmosphere. Sounds easy, but it's not that easy. First of all, we have to understand where we can make the biggest impact, not going into depth. I know we don't have much time, but just want to point out, beginning of the project, very, very early, that's the place where the big change can be done, where you decide, do you actually build or you don't build? Do you use the existing stock, or do you build actually smaller than everybody's expecting? And only then, later on in the process, all this optimization, all the clever materials, all the technology can really make the difference. At ARCO, we have been asking us in the last years, when we were starting the sustainability group and we understood we have to do a little bit more than just the classical architecture, we wanted to specify ourselves what is really a sustainable project or a sustainable building. And today we have been discussing a lot about this big bubble here, the greenhouse gas emissions. But we also know, and of course, material and operation, everything included, but we also need to remember that there is much more than that. It's about how long the building lasts, how the buildings are in relation to the nature, and how social sustainability can be understood, the relation between the society and the city and the buildings. But for me, this sentence is quite important. What we want to improve, we have to understand first, or we can only improve what we know. And that lead the sustainability team in ARCO, which has been starting pretty much in 2020, to the point where we are now. We have been doing a lot of collaboration with software developers. We have been doing a lot with One Click LCA, with other softwares and tools, of course. And we have been discussing with a lot of collaboration firms in order to be one day ready to really make sustainable buildings. And not only every 10th of the building should be like this, every building should be like that. And since the title of the speech was how to change the design process, the method, I've been trying to collect here the ingredients is what we need for making things a bit more sustainable. And we think that there are 5 big ingredients. One is that also the architect has to be really active in steering the carbon emissions, meaning doing the calculations. Reuse and circularity has to be taught much, much more than it is today. Efficiency in terms of space use and in terms of energy is one thing. Biodiversity is the other thing. And then the last one, Panu mentioned it in the entrance talk already. Many things can be done in terms of checking our impact on the environment with analytical tools. Let's use them. I'm not going much in this theory. I have some slides that shows buildings at the end. But let's go quickly through these 5 ingredients before I'm switching to explaining you how these have been used at the building level. So what do I mean when I'm saying the architect should be active in steering towards decarbonization? I know we have special consultants and they can do the calculations probably more precise than us. But we feel that if we are not understanding where the carbon is located in our buildings, we can't make them really better. We can't just always wait until somebody tells us what to do. We have to get the feeling ourselves. So we want to sit on the table at the very beginning. We want to identify the decarbonization potentials with the clients and with the builders, make the guidebook, make the roadmap. And then I think this is maybe something what I want to point out, especially we think the right tool would be to make a lot of rapid carbon comparisons during the design phase, not only at the beginning and at the end, to have the entire design phase totally connected to carbon emission calculations. Whenever you have to make a design decision, you should know what it means. And therefore, we think that the architects have to be skilled to do the calculations, to get that integrated carbon emission accounting goal. Using the existing, of course, renovation will be on our schedule much more than it is today. A lot can be learned from these old buildings. A lot of new tools are needed to make these constructions more smooth, all with the motivation, let's minimize the demolition to the absolute and maximize the lifespan of the buildings. This one is maybe my favorite, has also the most difficult title, efficient, versatile, confident, probably a little bit too much. But what I want to say is, let's try to create buildings that are smaller than they were in the past, but smarter than they were in the past. Let's try to put in a little bit more functionality, a little bit more flexibility, a little bit more optimized, and just let's build less but better and save carbon by that. When it comes to nature, we know, unfortunately, we are killing a lot of nature. We are killing a lot of biodiversity. Let's be much better on bringing that back. When we put buildings on the ground, there will be more coming later. And then the last ingredients is, let's not wait until the high-rise or the mid-rise comes up in the urban landscape. Let's check the impacts of it before. And that refers to thermal, wind, noise, humidity, anything can be almost simulated nowadays. And the architect should use those tools to be really sure that what they do has a positive impact and not a negative one. So let's do some examples, still good in time. I'm going in the same way through the ingredients as first few examples where we have been training ourselves to do carbon steering in the past, and then I'm going through every of the 5 ingredients and show you some examples. So carbon steering starts in the architectural office very often when you do a competition. We have now set up the workflow in ARCO like this, that the sustainability team will support the competition teams very, very often, and we help them to build up scenarios, options, and do the baseline calculation and find out what kind of decarbonization level you can reach with certain solutions. And this is the start of the project. That was an Oulu competition. This is the end of the project. This is Lyra in Helsinki. Maybe some of you know that new building quarter close to Hakaniemi. And there we were trying, can we actually, as the architect who is managing a lot of data on a BIM level, on an IFC level, can we do similar things for the emissions? Can we pull in the information from structural model, from architectural model, from the manufacturing side, from the client, and do the as-built calculation? We were training and checking how much time, how much effort, what kind of workflow has to be built up for one part of the Lyra project for the housing part. And we managed to get 95% of all the quantities from the 3D information and using One Click LCA, as in almost all our projects. This is a project that shows the reality quite well. It's a very ambitious client. We are building an office building in Valila at the moment, but the decision on what kind of frame, structural frame is used is very often pushed really far in the process. So we didn't want to give up and didn't want to give up doing decarbonization strategies just because we know that the biggest emitter, the frame, isn't decided. So we were going down in the hierarchy list, and we noticed that the interior surfaces in such an office building would count 15 to 18%, foundations not included in that calculation. And then we were together with the interior architects, we were doing different versions of customer spaces, toilet spaces, looking at floors, walls, and ceiling, and you see the cloud of the emission, how much you can push it down if you try hard, and you can still have a very interesting interior design. How do we do that? Probably as many of you who are doing the calculations, we're using One Click LCA in the center. We're using ArchiCAD, Revit, Solibri to feed in the data. We're using the rule sets. Very grateful that One Click LCA offers that all. We're using the EPDs or the generic ones that comes from the One Click LCA database. And we can do actually quite many different small calculations or comprehensive ones, comparing different building volumes, comparing the frames, comparing material setups, facades, slab systems by ourselves, and trying to get the feeling how well the building behaves in terms of emissions, or how stupid decisions we sometimes do just because we like very much how it looks. If I go to the second ingredients, the mastering the circularity, it's a little bit a different approach than what we heard in the Tampere case. I'm not going into using the tiny bits of materials, but we think that we are lucky that we can learn from these great historical buildings. We have been renovating these 3 hotels in Helsinki, and we have to really get ready for the future where in 2040, probably 2/3 of all the building stock is already there. And we can now learn from these lighthouses, because in the future we have to be much more creative, because they will not be always so interesting, the buildings that will be renovated. We know that the emissions are always much lower. This is not a calculation from us. It has been done from the sustainability consultant, but everybody knows that in the emission level, there is no way that you can beat a reuse project versus a new project. An interesting project from Doha, where the client was asking us, we should do a comparison between demolishing an existing high-rise, which was not very successful, was actually never taken into use, or can we actually do something to it to give it a new skin? Together with Rambo, we were developing a system adding a belt around the existing core, creating a new shape and creating a new functionality of the building. And this type of urban mining is just one example to use the materials what you have available in the city already. 80% saving according to some preliminary calculations. The motivation that a building will be demolished or not is not always on the architectural side, but I think if we have fantastic tools available, and we do have them available, we can still motivate many clients to go the step and to renovate rather than to demolish too early. Nowadays, we're doing in-house 3D laser scan and photography inventory models ourselves and kicking in the BIM level already in very early stage. We all know that BIM has a lot of sustainability benefits, less waste, less mistakes, much better collaboration. So let's use it also in the reuse projects very early on, and that inventory model is one of the important things. The efficiency and the versatility. Is it possible to build the same what you have been building before on a smaller footprint? Is it possible to get a demand from a client to increase by 1,100 students or 18% without building new? Our Tampere and Turku ARCO branch has shown it that it's possible with a very different design method, with a very participatory design process. A lot of data collection has been done, a lot of client communication or user-centric communication has been done, and many of these campus projects, they actually survive without adding new functions, just by finding new synergies between the different functionalities. And things like this can also be used for new constructions, just to be much more smart in terms of operation and much more space efficient. We believe that in the future, new building typologies are needed. This is a parking house pilot, what we've been doing together with Ramboll as well, and the parking house operator, where we were envisioning to build now a 5-story parking house. What we all know will not be needed in 10 years, maybe in 8 years in that extent. So we wanted to plan it already from the beginning for multiple scenarios. And I think that is a kind of exemplary case for many other building typologies. I think we should never plan anymore just for one function. We should assume changes to come up, and the building should be ready for that. And in this building, we have been envisioning changing part of the housing, part of the parking floors to sports facilities, to housing, to community spaces, and seeing the building really as a toolbox, as a material bank, and trying to develop together with Ramboll the connections in the structural elements to be reversible, agile, so that the building would last longer than 50 years. In the housing sector, we all know this is all done. You don't make a floor plan anymore that is only good for one scenario. And also in the facade design, this is a facade of Tripla in Pasila. The design for disassembly, easy maintenance, easy changing in the background should be considered. The big potential in these big firms like ARCO is that you have a lot of experts in-house, what you don't always have. So we have landscape architects and ecologists in our office, and we're trying to boost this biodiversity, learn from them, work together with them on many projects, and creating this kind of sustainability guidebooks for tenants or for clients, in this case, YZ, more and more, and promoting the idea that we really need living systems. We don't need artificial green spaces. We need living systems like real nature, and we have to bring back as much as possible of them to our sites. And the courtyards are not enough. We have to go on the roofs, on the facades, and have to use every single surface what we find to bring enough biodiversity back. The last ingredients is the environmental analysis. And as we saw already, the announcement, One Click LCA is now joined with EnviMet. This is one example of this. We have been starting to use this environmental analysis, different softwares early on. I think that project is already 5 years old. And it's a good example on how a building shape can actually be influenced by data or by environmental analysis results if you're open for it. We have been developing many building volumes for that specific site in Malmi for the student housing purpose, and we run all of these 10 totally different volume options through environmental analysis and checking the daylight in the courtyard, the daylight on the facade, the noise pollution, because it's on a really noisy spot. And at the end, the winner of the analysis was a circular building where all the windows of the student homes will be inwards towards the courtyard, which is wide enough, which has a big opening to the sky. It has a sloping roof to catch more daylight, and to has this kind of thick walls to block against the noise. Similar tools were used to build in a very different climate region. This is Asia. This is Dhaka in Bangladesh. We are constructing at the moment that 138-meter tall high-rise there. And the client was very keen from the very beginning on to have a lot of pocket gardens, a lot of green roofs, to bring a lot of green onto the building. And we wanted to be sure from day one on that, first of all, the building aerodynamics is working in a smart way, but also that all these spaces, what we create, that they're not just decoration, that they're really safe to use, but that they're also really comfortable to use. So with this environmental analysis, you can actually do that. You can forecast 20 years, 10 years. These buildings take quite long to build, and check the local microclimate. How comfortable will these spots be? Or will they be just a decorational add-on that is using carbon emissions but doesn't bring any benefits? This was done with a different software. Nowadays, we are learning heavily EnviMet that Panu was already promoting at the beginning of the session, which gives us much more insights, which is much more customizable, where you can decide if you want to work on a master plan level or if you want to zoom in to a tiny courtyard or to an entrance area, and you can really simulate the thermal comfort, the wind, how well the plants will grow in that condition, how much of an impact a green wall or a green roof has on the microclimate. And you have, let's say, the scientific proof of it. It's not just the feeling or the intuition of the architect, it's scientifically proven. So this is a huge motivation for us to check also projects not only in these hot climates like in Bangladesh, and use that also on the Finnish level. A lot of tools have been developed earlier for trying to create climate responsive facades, understanding the solar values on different parts of the facades, and then creating the right glazing for the right spots. And many more things should be done, but there are limits. But the last slides, what I wanted to show you, is a project that is at the moment in construction, which combines a lot of these thoughts and a lot of these new ideas, new tools, widened processes, not thinking as the architect only anymore about the stability, the function, and the beauty, to widen that branch of tasks what we have. And this is Keilaniemi in Espoo. I think it's for sure Finland's tallest office building. When it was designed, it was also the tallest one in the Nordics. Almost fully made out of renewable material, a lot of engineered wood in it, and collecting a lot of these items, what I mentioned, a lot of these kind of ingredients is what we think should be used for sustainable buildings into one project. So it's a smart volume. It has been placed on a site in between a road, very challenging site. No, not many people were thinking that you could actually create a building there. It's full of sustainable materials. It has glulam columns. It has wooden slabs. It has concrete only on top of the slab. It has a lot of recycled materials in it. It's of course low energy, and it brings the nature back on the building and into the building in order to create a better connection between the human and the nature, and that will boost the well-being effect of all those workers in it, hopefully very much. And to have the chance in Finland to build so much with exposed wood and put it in the landscape of the metropolitan area, combined with the 55% reduction from the baseline, should be a big motivation for everybody to do more of that. So maybe I was running very much, but I'm glad that I made it through my slides, and happy to answer if you have questions.
Thank you, Stefan. You can stay here on the stage for a while. So, do we have any questions for Stefan at this point from the audience? Here.
Thank you, Miika Liukka from Olla Architecture, also here in Helsinki. The last timber building that you showed, I'm interested in the exposed wood surfaces. Was there any problems with fire regulations when having so much wood in the interior?
There are some special simulations done, and I'm also not fully sure how many walls can be really exposed, but it's a huge ratio. But since it's such a special building, and in Finland you're lucky that you don't need to follow the fire code like 1-to-1, that once simulation is done, everything is of course sprinklered in the building anyway. You can apply for a lot of exceptions.
Thanks.
Yeah, I think it's very much up to the creativity of the fire consultant you have on board.
All right, some variation there. Any other questions? Sieltä, Taka.
Thank you, Stefan. You mentioned space use efficiency, and you did have an example on that topic also. But is there anything else? Would you like to extend on that theme? Because I think we can see like that also architects don't really have an incentive to reduce the amount of built area. It's probably profitable to build more. So would you like to elaborate on the thought?
Yeah, there are tools. They are not so straightforward as One Click LCA. I think it has a lot to do with the brain work that the architect has to do, and has a lot to do with collaboration with the clients. Just you have to be much more. I think you have to open up a little bit the perspective, and don't think that this is now an office building and therefore it's 100% office use. To really bring in this mixed use and this kind of synergies between a building. I have the image of the mall of Tripla. Not saying that this is the most efficient building, but it shows a little bit this extreme hybrid. And I think if you would have built all these functions, what you have, for example, in Tripla, spread over the city fabric, it couldn't be that efficient. But yes, there are special tools. There's a company called Delphi. We are working quite heavily together, for example, on the healthcare sector, and they kind of analyze the whole flow of goods or the whole flow of operation in the building. And if the architects are starting to be open to listen to many different partners and working together with firms that are maybe not directly related to architecture, then I think we can achieve this kind of shrinking the buildings, pushing it into a smaller frame, but still achieving a better quality on the inside. But yes, the tools are not that easy in this case. A lot of brain work and some specialists needed.
All right. Anything else? I guess no. I really like your kind of perspective that whether we're, different stakeholders in the value chain, we all actually need to step up and provide kind of more service to our clients, because of course the clients don't always know what they want and what's possible. So it's our job to kind of give those scenarios and those possibilities so that they can actually make those decisions.
Yes, and I think it's the best thing if you feel that you're in an urgent situation, and if you can gain a lot of motivation from it, that you're not getting depressed and you're not getting frustrated from the fact that we are in deep trouble, that you can push these kind of negative thoughts into something creative and something positive.
Good job. Thank you, Stefan.